All right, hello and welcome to another engineering lesson. After my last video, I got a little bit of feedback. Okay, I got one comment from someone who said they preferred the video lecture at the whiteboard to the disembodied voice talking over a PowerPoint. And since that's the only feedback I've gotten either way, I've decided to try it again. And so today we're going to be talking about pneumatics. And so let's see, because it's an interesting word to see spelled. Um, we're talking about And so we've been talking about hydraulics. I just want to talk a little bit about how pneumatics are different. Hydraulics are using a liquid for the fluid. Pneumatics are using a gas. So remember, gases are also considered fluids. And so we can do most of the same things we can do with hydraulics, we can do with gases. Now there are obviously different properties to gases and liquids. And so the behavior of the systems are a little bit different. There's different advantages and disadvantages. The biggest difference is that a gas is compressible. So I could not do this with a liquid. What I have here is a piston that's moving up and compressing that gas into a smaller space. We could do that with the syringe that I had the other day. I could actually cover up this end and I can kind of push that down, and I can feel as I push it, it's getting harder and harder, and then it springs back up. And so because it can be compressed like that, we can say, hey, this actually acts quite a bit like a spring. I can compress it, I can store energy in it, and I can release it, and I can get that energy back out. I can't do that with a liquid. If I tried to cover this up with this end and tried to push on it, it would not compress. It would not go in unless I sprung a leak somewhere. So the interesting thing is, as I said, that does allow us limitedly to store energy. To go back to this, put it down just to get it right back up. This is actually one of the systems that there have been at least some work done to actually store energy and to be used with renewable energy sources. So we know that one of the big downsides of, say, solar power or wind power is that the wind isn't always blowing, the sun isn't always shining, so you have to be able to produce extra power when the wind is blowing to store it for when it's not. So one way you could do that is you could take that extra energy and use it to compress a gas. And then when the wind's not blowing, you allow that compressed gas to work on a generator to produce electricity. There's limits to that because one of the things that happens when you compress a gas is that it heats up. And so unfortunately what happens is some of the energy you use to compress it actually becomes thermal energy instead, and as you store it, it cools down, it comes back down to room temperature, and all that energy that went to heating it is lost. It's wasted, you don't get it back. So it's not especially efficient. Now if we could find some way to change that, maybe it'd be better. But it is a mechanical method of storing energy. So it can also be used to transfer energy, as can hydraulics. But I think I've talked about in an earlier presentation. I actually visited a gold mine once. It was no longer in operation, but I still got to see some of the old equipment. And one of the ways that they did operate was to use compressed air to transfer power from the surface down to the workers. And this had several advantages. Maybe it was in a coal mine too that I also saw it. Coal mine would be especially important because electrical devices can spark, and so you don't want sparks around something flammable. Gas-powered thing, but even in a gold mine, if you had, say, gas-powered tools, that'd be problematic because then you'd be using up the oxygen, and you're underground in these tunnels where there's not a lot of extra oxygen, a lot of, airflow or anything like that. So with these air-powered tools, you can compress the air, send it down through hoses to the tools, run the tools, no sparks, and it's actually putting air into the environment. So it's kind of cool. Anyway, let's talk about Pascal's law for pneumatics. Because even though I could not really clearly articulate why Pascal's law is a thing for hydraulics, I can for pneumatics. So here's the deal. Here's my system. And let's say I compress this side of it. And so I'm now pushing these molecules closer together. And that's, I should have said this earlier, but that's a fundamental reason why a gas can be compressed and a liquid can't. A liquid, the atoms that make up that material, that substance, are already as close together as they can be. They can move past each other, but they can't get any closer. A gas is mostly empty space. The molecules are 1,000 to 2,000 times further apart than they are in a liquid. And so they can be compressed quite a bit. They can be pushed closer together. So let's say I do that. I push these closer together. Now these molecules are always moving around. They're bouncing off the walls. That's what produces the force. That's what produces the pressure, the collisions between the atoms and the wall of the container. So if I were to compress this side, these molecules would be closer together and they'd be colliding more often. Which means this molecule right here is more likely to have a collision on with a molecule on its left side than on its right side, which means it's going to get pushed to the right. And so what you can see then, because if there were a difference in pressure anywhere within this container, then things will be pushed towards where there's lower pressure. There'll be more collisions on the high pressure side and fewer on the low pressure side, and they'll be pushed to the lower pressure until the pressure is the same everywhere. And so when I compress this, however I change that pressure here, that same change happens everywhere as long as we have an enclosed fluid. And so that's Pascal's law. Again, that the pressure is going to be the same everywhere in this enclosed fluid. All right, I just want to talk real quick. The system for pneumatics looks almost just like hydraulics. I didn't draw it for some reason, but you would have, in a lot of cases at least, you would have some kind of piston that can do some kind of work. You'd have a hose that would come in on either side of this, so I can have air go into either the back side and come out this side, or go the opposite, so I can have air go in here and out here, or flip that around to move that piston the other direction. So what are the advantages of a pneumatic system? The processes tend to be a lot quicker with this because gas is compressible and can flow very quickly through something. You can imagine if I had really high pressure here, it's just going to kind of explode into that area. So it's a lot quicker, but it also creates jumpier motion. Not quite as precise, probably because it's faster and jumpier. You can't quite control it as well. They do have to be lubricated, but they're generally cleaner than hydraulics, but also generally produce less power. They're typically operating around 100 psi. And so that's kind of the gist of that. I am going to post a PowerPoint. The PowerPoint I would have done, there'll be some information there as well. But honestly, I think this more or less covers what I feel like mentioning about pneumatics at this point. So take care, and thank you for watching.